Hello everyone. Welcome you all on our channel eFunda for today's topic Pressure Engineering Guide Part 8. In this video today we will cover basic definitions of a pressure, various types of a pressure measurement technique and various types of instruments are being used for the pressure measurement. And if you are new to our channel, then watch all our engineering video series on various engineering topic, and don't forget to subscribe to our channel to get latest updates and reviews on various subjects. Let's begin with our today's topic, that is a pressure engineering guide. Pressure measurement is a very critical in day-to-day life as these values plays an important role in our life. Today we are planning to cover pressure, their definition, type and measuring instrument along with their application. Definition: pressure is actually measurement of a force acting on an area of a surface. Therefore pressure is equals to force by area, that is P is equals to F by A. Here we will see the pressure term relationship where one can see various types of pressures. You can see in a figure: absolute pressure, gauge pressure, vacuum pressure, atmospheric pressure and absolute zero pressure. Pressure may be measured with reference to arbitrary datum, that is absolute zero pressure, local atmospheric pressure, gauge pressure or vacuum pressure. Absolute pressure, that is PA, is equals to gauge pressure, that is PG, plus atmospheric pressure, that is ATM. This is how the pressure relationship is defined. Classification of a pressure measurement: mechanical, electromechanical. Under mechanical one can see there is static and dynamic. Under static, manometer, U-tube, well type, incline. Under dynamic, diaphragm, bellows, burden tube. And here today we will see in a brief, that is a burden tube. This is the most popular type of a measuring element for pressure type. C type, helical type and spiral type. One can see in a figure where we can see the various parts of the burden tube pressure gauges, where we can see dial, pointer, ring, window, seal, socket, solid case front, movement, burden tube, diaphragm, blowout back and a case of the pressure gauges. And in animation you can see the pointer is connected to the pinion, where based on the pressure applied on a burden tube, the burden tube will expand and accordingly the pointer will move and the pressure measurement value can be seen on the dial gauge. The units of a measurement are pounds per square inches, that is PSI, kg per centimeter square, bar, kPa, etc. And basic formula, that is 1 bar is equals to 14.5 psi is equals to 1.01 kg per centimeter square is equals to 100 kPa. 1 atmospheric is equals to 14.67 psi. Further it is equals to 1.03 kg per centimeter square, that is further equals to 101.325 kPa. This is how the basic conversion is done. Now we will see various types of pressure, their definition and application. Example in brief: gauge pressure, reference to atmospheric pressure. Applications: car tire, water level measurement, chamber pressure and hydraulic application. Sealed pressure, reference to a sealed chamber closed with a atmospheric pressure approximately 1 bar for use in aggressive media, industrial application, wash down environments and foods and beverages. Absolute pressure, the reference is a vacuum, that is a 0 bar or a no pressure. Barometric type, weather stations and meteorological applications. A differential pressure, measuring the difference between two pressure port reading. Filter and a pump monitoring. Air conditioning, HVAC, heating, ventilation, air conditioning, clean room monitoring. We will see few abbreviations and a unit conversion. Bar abbreviated as a bar, atmosphere is ATM, kilopascal is kPa, hectopascal is HPa, pascal is PA, Barias is a Barias, torically is a tor. One can see in a table various kind of conversions are shown: bar to atmospheric, kPa, HPa, Pascal, Baria, and tor. One has to practice this conversion so that it is easy to understand and remember as well, as these critical conversions will be used for designing of your pressure measurement techniques. Pressure measuring devices. Pressure measuring devices are logically divided into following categories: pressure gauges, indicator, differential pressure gauges, indicators, pressure and a differential pressure transmitter, pressure switches. These are the most commonly used measuring devices for pressure measurement. Pressure measurement. The object of pressure sensing is to produce a dial indication, control operation, or a standard 4 to 20 milliamps electronic signal that represents the pressure in a process. Objective is to measure pressure for monitoring and provide necessary controlling. Pressure measuring devices. Bourdon gauge. Principle: the change in curvature of the tube is proportional to difference of a pressure inside from that outside the tube. One can see in a figure dial type pressure gauges, cross sectional area of a parts indicating. Other figure we have shown the name parts for each parts inside the gauges, and in last animation one can see how the pressure is applied to the Bourdon tube, and based on increase in the pressure inside the Bourdon tube, the pointer connected to the pinion will be moved based on the movement of the Bourdon tube, and accordingly the pointer is attached to that pinion will get deflected, and in a dial type pressure gauges one can see the increase in the pressure. Application: a tire pressure, pressure at the top or along the valve of the tanks or the vessel. Few other pressure measuring devices: strain gauges, piezoresistive gauges, U-tube manometer, where these days U-tube manometers are being used for some applications where the hydrostatic law is being used, that is a delta P rho GH, where one can see the U-tube manometer arrangement where two legs are provided, where the pressure difference is shown between one leg to another leg, and that difference is called as the H. And further, the strain gauges, that is a principle where the delta pressure changes, that means change in the resistance. Similarly applicable to the piezoresistive gauges. Meters, it transmits the signal from one source to another, that is from field to control room for monitoring and a required corrective control action. Pressure transmitter, one can see in a figure where the solid frame is provided, inside that capacitance plate is installed, and high pressure side and a low pressure side can be seen inside the isolating diaphragm. Based on the acting pressure on a HP side and a LP side, the capacitance inside the diaphragm will be changing, that is the capacitance between two conductor will change. Area, that is overlapping area between those conductors, and dielectric permittivity of the insulating medium, and the distance separating those conductor. And this is how the pressure transmitter work. One can see the installation of a pressure transmitter which HP and LP side is connected with the help of manifold, where equalizing valve, block valve are being used, and the impel lines are connected to the process, where one can see the connection to the process line so that one can get the high and low pressure, and accordingly the readings will be followed, that is a 4 to 20 milliamps. Typically the transmitter look like is shown in the last figure, where the Rosemount transmitter is shown as a typical example of a transmitter. Pressure gauge accessories. Safety glass front. Safety glass is normally used to prevent the glass shattering in the event of rupture of the Bourdon tube. That means in worst case scenario the Bourdon tube broke, then that will save the pressure gauge by means of using the safety glass, which will not have an impact onto the operator. Liquid field. The liquid filling is used to dampen any vibration or pulsation in the Bourdon tube. Either silicone oil or glycerin is used. One can see in a figure where the oil filled liquid is placed inside the pressure gauge, where the pointer is under the liquid filled silicone oil or glycerin. Snubber, pressure gauge snubber are intended to suppress the effect of pressure pulses and pressure peaks, used for the dampening and filtering and further reducing the damping effect of a pulsation on a pressure gauge. This snubber has a metal disc available in standard grades of porosity, one can see in a figure, and these are the three critical accessories are required for the pressure gauges, and other accessories may depends on the application as well as the requirement from the client. With this, we are concluding on our today's topic, pressure engineering guide, and here we have tried to cover many aspects of the pressure engineering, where we have covered their definition, types and measuring instrument which can help us to get a exact pressure measurement. If you are new to our channel, then please subscribe to our channel and don't forget to press bell icon to get latest updates and reviews on various subjects. Keep watching eFunda. Stay tuned for new day and new topic. Thank you.